So thank you very much, participants, for coming and joining us tonight for the sixth installment of the Warekada series. And the Warekada series is a series that PERMIAS Nacional has been hosting throughout this academic year. And Warekada means berbincang in Bahasa Bugis. And so we just really wanted to get the perspectives of, particularly of a lot of grad students and faculty, Indonesian faculty in the US, and to learn about their fields. And so today, so previously we've covered topics such as economics, business school, biomedical studies, and today we'll be talking about civil and environmental studies. And we're very, very lucky to have our three speakers here today. And so, yeah, just wanted to introduce them just very briefly, and then we'll jump right into the conversation. And so, first of all, we have Professor Rahardianto. And so Professor Rahardianto is an expert in water purification and desalination with significant contributions in membrane fouling/scaling fundamentals, high recovery desalination, advanced desalination processes, and real-time membrane fouling monitoring. He was formerly research scientist and assistant adjunct professor at the UCLA Chemical Engineering Department. He also co-founded and was formerly the CTO of a technology startup focusing on real-time membrane fouling monitoring. Professor Rahardianto has pursued his education and career in the United States since high school, earning a bachelor's and a doctoral degrees in chemical engineering at UW-Madison and UCLA, respectively. To date, authored and co-authored 35 peer-reviewed journal articles and is co-inventor in multiple patents and patent applications. He has served as co-principal investigator in various federal, state, and industry-sponsored research projects in the US. And he is currently serving as the associate editor-in-chief of the IWA journal, Water Reuse. So welcome. Second, we have Kafrida Seregal. Kafrida Seregal is a recent graduate from the Harvard Kennedy School of Government. She previously worked at JPAL Southeast Asia in Jakarta and Evidence for Design in Cambridge, Massachusetts, doing policy outreach and developing randomized evaluations in Indonesia, India, and Pakistan. She is currently a researcher and specialist with the World Bank and Mahkota, respectively. Her work focuses on improving public service delivery and social protection. And for her master's, Kafrida and Jane Tajajono conducted a policy consultancy for Jakarta's province's TGUPP. The consultancy explores Jakarta's solid waste management with the question, how can Jakarta reduce or divert household organic waste from the landfill? HKS awarded their project with a distinction. Welcome. And finally, last but not least, we have Irene Alisjahbana. Irene Alisjahbana is a PhD candidate in structural engineering at Stanford University. She earned her bachelor's degree in civil engineering from Universitas Indonesia and her master's degree in structural engineering from Stanford University. Born and raised in Indonesia, a country often struck by major disasters and earthquakes, Irene is inspired to help disaster risk worldwide. Her research focuses on developing quantitative models to study the recovery process after earthquakes. In her research, she applies her models to case studies in Indonesia, particularly after the 2018 Lombok earthquakes. Ultimately, she aims to use these models to assess the impacts of earthquakes and help governments in decision-making to recover faster. Outside of academia, Irene has also been a mentor in Indonesia Menglobal's annual mentorship program for the past couple of years. And so, as we can see, like we have a lot of each of these our panelists come from very, very diverse backgrounds, from computational methods in civil engineering to public policy to desalination. And so, yeah, we're really, really excited to learn from them tonight. And yeah, I guess we'll just jump into the first question. Um, and so yeah, just as the rest of our Warekada series talks start, yeah, we just wanted to kind of from each of you, and I gave a very like quick summary of your history in academia up to now. But yeah, can you just talk about the personal side of how you got to where you are today, and how you got into the interests that you are in? Yeah, so anyone can start.
Okay, I can start since you introduced me the first as the first one. So I just wanted to, thank you for the kind of introduction. Very happy to be here to share my experiences here in the US. I hope it can be of benefit to everyone that's watching this great series. But first of all, I just want to say that, having been involved in PERMIAS, Madison, it's the Indonesian Brewing Student Association, and PERMIAS LA many years ago. I'm quite impressed with how PERMIAS National has evolved. So I thank you, for advancing the PERMIAS organization. I was actually very surprised to find out that there is now PERMIAS National. So congrats to that. Just to delineate again that I'm no longer at UCLA as of the end of 2020. I'm actually moving back home to Jakarta in about a month, for a new opportunity there. So right now it's really quite an interesting time for me because I've had quite an unusual but rewarding career here in the U.S. I've been studying and working in the U.S. for almost 26 years now. So I was born in a small mining town in Papua. Probably you've heard the town. It's called Tembagapura. When I was 16, I had a scholarship to finish high school here in Los Angeles, and I decided to study chemical engineering at the University of Wisconsin-Madison. So in my senior year of college, I did a co-op, and for those who don't know, a co-op is like a 9 month long internship, so it's like an extra long internship. I had a co-op in a chemical plant in Chicago, which exposed me to a little bit of applied research, working on evaluating a new technology at the pilot scale. So this is, I think, was the point where I thought that, oh, you know what, I really wanted to go into applied research, and went on to pursue a chemical engineering PhD at UCLA. A little bit about applied research. I think when we talk about, let's say, a conventional PhD program, you typically do basic research, right? Focusing on a specific set of fundamental problems. The goal really is to discover fundamental principles that can lead to important application, electricity, lead to incandescent lamp, and electric cars, things like that. Applied research, it's usually goes the opposite direction. You start, with real world application with practical, often commercial problems. You try to develop specific solutions for those problems, often in a very empirical way. But you do enough of this, you start to discover some of the fundamental principles that help you generalize your solution, and this is how you get, your PhD. So I think both approach is valid. I think to for a PhD program. So I followed the second approach, and my research was primarily focused on addressing the issue of water scarcity and water contamination, and this is through water treatment and salt management technologies. Uh, I think many of us know that less than 3% of the world water are fresh water. Most of them are seawater. You can't drink those, and even the fresh water, they're dwindling due to contamination, and they're hard to access. So we are at a point where it's really hard to maintain our current water resources. Even in California, recently we've had a lot of experience with drought and problems with water resources. So technologies to treat contaminated water and produce new freshwater resources, let's say from salt water or from wastewater, are critical to human survival. So one of the most effective technologies to treat contaminated water and to desalinate salt water is reverse osmosis, or it's often called RO, singkatannya ya. It's essentially a special filter or membranes with very, very tiny pores. When you apply pressure to salt water on one side of the membrane, water permeates through the pores, but particles as small as ions basically are rejected by the membrane. So in RO, a fraction of the salty or contaminated feed stream that permeates through the membrane becomes freshwater, your product, and the remaining fraction is a waste stream of concentrated solution, right? So the higher the fraction of the feed water that you extract as fresh water, the more efficient your process is. So this is called, the water recovery. The fraction of fresh water from the feed water is called the water recovery. But the side effect is that the higher the water recovery, the higher the concentration that the system is exposed, to higher salt concentration. So this has various practical implications. The more concentrated, the higher pressure that you have to apply to overcome the impact of this phenomenon called osmotic pressure. Basically, salty water has osmotic pressure, and this can impact energy cost. Also, concentrated salt solutions are often not as stable because those salt, as they get concentrated, they fall out of solution, they precipitate out of solution as solids. And what happens if you have a filtration process that has solids? They plug, the membrane. They uh, they they block the membrane, so water cannot permeate through. So you have to apply higher pressure, and eventually your membrane becomes damaged, and you can't use it anymore, right? So you don't want that to happen. So if you don't go to high recovery, you go to low recovery, then your process is less efficient, and you produce less water and more waste. And where do you dispose those waste? So those are essentially the two major problems that you have to be able to manage with. So in my doctoral research, I explored and developed new ways. Sorry about that. I hope you hear my little dogs. I think there's something. Anyway, so uh, in my doctoral research, I explored and developed, new ways to characterize, monitor, and manage salt in desalination processes. So, for example, I developed, various novel processes that integrate reverse osmosis with precipitation processes. So the RO itself, you use it to produce the water and the concentrate the salt. But as the salt becomes concentrated, you can use the precipitation process to remove the salt, and now the water has less salt, so you can process it, through the RO again and get more water out of it and maximize water recovery. So we managed to advance the technology from bench scale experiments to production scale demonstration, which is, I think was quite an interesting thing, doing it at the doctoral level, because, you actually get to work with, industrial type systems, which often is not something that you would see in a PhD program. Later on in my scientific career, I expanded my research to advance our desalination technologies. This include, projects, leading projects on advanced RO process design and control systems for smart, self-adaptive RO operation. A lot of words there, but it's the easy way to say it is just it's like trying to develop the RO version of self-driving cars, right? So that it's easier to operate. You don't need a lot of expertise. And this is critical because more and more of these RO processes are being used in many different applications. But a lot of time, the problem is not about the technology itself, but it's the human resources to be able to operate those systems, can be challenging, especially when in applications that has to do with remote communities or disadvantaged communities, which, I also worked on. So that was pretty neat. That led to about 3 patents in water technologies, and I was also involved. Other than that, working on novel membranes to that faultless, so it resists the accumulation of things that block the membrane. Also involved in other projects doing remote our system for remote and disadvantaged communities here in California, dealing with the issue of nitrate contaminated drinking water. So that was also an interesting project that I was involved in. So a few years back, I co-founded a water technology company with a number of my colleagues. I serve as a chief technology officer responsible basically for developing the company's first product. We basically developed a technology that allow our plant operator to monitor the membrane surface in real time and to enable so that you can take corrective actions to protect the membrane against membrane fouling, which is like the accumulation of particles that block the membrane surface and cause a lot of problems. So, I guess the selling point was we were trying to develop some kind of a Zoom for RO plants, like the Zoom that we're using right now, but for RO operators. So I think this was probably a period, one of the most exciting period in my life, yet stressful, because as in addition being an academic in one side, I'm also involved, uh, in a startup. So it's almost like having two full-time jobs, although officially you're like part-time and part-time. But I think this is where you have to sort of like test yourself to stress yourself in terms of expertise. Like knowing not just your field of expertise, but knowing of other things that sometimes just really out there, right? Your time and your commitment, and I think at the end it was worth it because I think even though I think because I think I was successful to develop and bring like the minimum viable product, the MVP, to the market that allows us to raise significant seed funding in projects. But I think at the end, and I think this is true with many of us, is that with success, sometimes you reach a point where you have to be honest with yourself, where whether or not this is what you want in the long run and how much more you can grow. So I think with the pandemic right now, this is it's like a time for self-reflection, right? So and during that period, I think one of the most important thing that I found was like like moving back to Indonesia is the right move at this time. So even though I've been here for a long time, looking forward to going back there. Um, that's what I have, and hoping to learn from the rest of the speakers as well about their experiences.
Thank you so much. Yeah, Kak Irene or Kak Frida. I guess Kak Irene, do you want to go next?
Okay. Yeah, I can go. Yeah. Before I start, I guess, yeah, thank you for inviting me to be a speaker in this series. My background, I mean, Ricky, you already mentioned a little bit. So I started, I grew up, I was born and raised in Jakarta. I did my undergrad in UI, in civil engineering. And then I moved to the States in 2017 to start my master's in structural engineering. And structural engineering is like the classic you designing a building or a structure, a bridge, I guess. But I wasn't really interested in that. And so when I started my PhD, I decided I wanted to do something more macro scale, which is why I ended up studying what I am studying right now, which is studying the recovery process of regions after earthquakes. And this is a little different term of recovery than what Prof. Rahardianto said. But in my case, recovery means like how regions or cities reconstruct after a disaster hits. So when their buildings are damaged, how long does it take for governments to reconstruct all that building? And how can we get it to become faster? And how we do that is we basically make simulation models. So we simulate an earthquake in a certain region. As Ricky said, I normally do my case studies in Indonesia and also actually in the Bay Area. So we simulate, for example, an earthquake happening in the Bay Area, and we simulate which buildings will be damaged after that earthquake. And then knowing which buildings are damaged, we have simulation models to predict how long it takes for each buildings to be reconstructed. And so, yeah, does it take several years, 5 years, 6 years, and so forth. And lately, I've also been including socioeconomic information. So I'm looking at inequalities that happen when you're recovering after disasters. So what is the difference between households that have high income versus households that are low income? How does that affect their recovery? Will they be able to recover faster because they have more money, or yeah, and like how different they are between the two. And then, so that's what my case study is in the Bay Area. As for Indonesia, I do a lot of research after the 2018 Lombok earthquakes. Fortunately, they had a lot of data that was collected after the disaster and how they reconstructed afterwards. And that kind of data is very rare worldwide, actually. So the fact that Indonesia had that data was very, very valuable for, I guess, disaster risk research area. And so I'm using empirical data that was collected after the earthquake to, I guess, develop models that kind of like match that and can be used in the future to help predict and help governments decide. For example, after the disaster, there's like 100 buildings that needs to be reconstructed, but there's only, I don't know, 10 contractors or reconstruction crews that are able to rebuild the buildings. And so which one should we rebuild first? And that's, I guess, some of the questions that I'm trying to answer. Yeah, that is, I guess, my extent of my experience. Definitely not as long as Professor Rahardianto, but yeah, I'm just glad to see all the different backgrounds and different expertise in this huge field.
Thank you so much. Farida, please, last but not least.
Cool. Right now I am a researcher and a specialist, and my focus is on improving public service delivery. My main areas of interest is really about how we use data, technology, design thinking, impact evaluation to improve how government delivers its delivery. And this, is a very generalist interest. I'm interested in this from like the social protection point of view, from like the public health point of view, from taxation. And so like all of this really started off when growing up, I moved around a lot because my dad was in the foreign services. And so every new place brought with it a very different experience of the school, of like traffic, of like going to the groceries, of daily life. And I think that really impressed upon me just how different life is for different people, and depending where you are and where the accident of where you are born into. And I think that was sort of where my interest was piqued in terms of how we can, make opportunities and make like life experiences more available to all. Before I when I was at Harvard doing my master's in public policy, my focus actually was not on environment, but that was one of the areas that I wanted to explore through my final project. And so that the nice thing about being a generalist, and I think about going to school, is that you can take risks. And the way that I did that for my master's program was to do this consultancy with the governor's office in Jakarta. But prior to that, what I was coming from really was the intersection between policy and research. I worked at JPAL, as you mentioned, in evidence for policy design, and the thing was, working with people in the government and working with researchers and working with implementers on the field to look at programs that were up for reform and say, we want to reform this. What's the best alternative to the existing program? And then you trial different methods of that on a large sample, and then you see how. And because of randomization, you can see how the program actually impacts the outcomes that you get. But yeah, so my background is actually quite a mishmash between like social protection work, looking at programs like RASKIN and BPJS. And like currently today, my focus is more on improving social program delivery at the national level.
Yeah, thank you very much. It is really, really cool to see how, all of you have very, very interesting backgrounds, and I feel like they are also like different things about our everyday lives that we often don't like for example, like how do we actually get like water that is purified and clean, to Professor Rahardianto's project, or like how do we manage disaster, or like how do we implement good policy for a city of 20 million people in the case of Jakarta. And so I think that was really, really interesting. So we just have a few questions before we will open it up to the audience. And audience, I think we also posted in chat a link that you can add questions. So you can add questions, or you can upvote some questions, and we will ask that after one or two questions that we have prepared. And so I think one thing that I personally am really, really interested in is often like civil and environmental infrastructure requires a lot of like government contribution, right? Like if you want to work on disaster relief, right? Like you need to coordinate with the government, right? And I guess like my question in this field of civil and environmental studies is generally, where do you see the role of in your research, what do you see the role of private and public actors, and what do you think is the future of the field in terms of those different sectors? And this is to anyone that would like to answer.
I'd like to maybe say something, but with the disclaimer, of course, that for like my focus is not on environment policy or like how decisions are made in civil engineering, because I think that there's probably like a more technical, like the component of technical input is probably much higher than other fields. But I think that, so when I looked at when I did my final project on waste management in Jakarta, we like invested our 9 months, talked with people in the field, did our work, and then at the end of it, we presented our recommendations, and COVID hit, right? And so all of the considerations that we had put into balancing between, what was politically feasible, what was administratively feasible, what was, actually going to bring impact, all of that kind of had to go out the door because government's priorities had changed. And I think when you're talking about government funding for these projects, it often depends on, what is politically feasible. in public policy or public administration, we look at three things. Technically accurate, so what's going to create impact. Second, we look at administratively feasible, so like, can we actually roll this thing out? And lastly, politically feasible, like, is this something that is just going to be a regulation, or will it actually be rolled out? And I feel like that aspect of like the political reality, like, is there a crisis that's motivating this? Is this on everyone's mind? Is there a lot of pressure that has a huge impact on what's feasible or not from the government point of view?
So the question that you posed was whether or not public-private partnership is critical in infrastructure development. Is that it?
I guess that is one aspect, or
Okay,
just
that's one
like
aspect.
the role of public sector, right, government, and the role of like private sector, right? Like the role, like for example, you're a startup, some might have had, right? There's these two different sectors, but both of them definitely contribute some parts. I'm just wondering like what your insight is.
Sure. So I mean, like from my perspective, I mean, like in the area of water, public-private partnership is a must, because a lot of the water utilities are owned by the public, or even though maybe they're operated by the private industry, but essentially they are serving the public. So just from the funding point of view, from the regulatory point of view, the government has a big impact there. A lot of the technology providers are coming from the private sector, but the research money that lead to a lot of the discoveries are coming from public agency, at least in the U.S. So I think from even like the funding part, the regulatory part, everything has both the public and private partnership. And one of the things that I think, one of the experience that I had with this public-private and also a university partnership of the university in the U.S. often is the public. I mean, it is governmental, part of the government, especially for state university. We were working on a project basically that focused on treating nitrate contaminated water in the U.S. in some of the disadvantaged communities in Northern California, right? So can you imagine in the U.S., there are pockets of areas where people are drinking contaminated water, and the state is responsible to make sure that they get taken care of. And one of the solution was with water treatment, but the problem with water treatment is that a lot of the regulation are designed for very large scale systems, while the areas where it needs solutions are small systems. So there was a lot of negotiation back and forth between the private sectors and the government sector of how you deal with that kind of mismatch between what the regulatory is supposed to serve with the actuality in the field. So, and this is where things get a lot of pretty difficult, because different actors have different liability and different perspectives on how things are supposed to move. So the short answer, yes, it's critical.
Yeah, and then I can comment on the disaster risk side. Obviously, the public sector is, again, very, very important, regardless of the country, especially in Indonesia, because the government is primarily in charge if there's a disaster that happens, and they're the ones that subsidizes a lot of the things, and it's basically responsible for the reconstruction. Perhaps less so in countries like the US or Japan, where the private sectors are actually the ones that play a major role also, given that a lot of the infrastructure and buildings are insured by private sectors. So I guess for the disaster field, it really depends on what country it is. But in terms of like how researchers play into it and like what the future holds, I do think researchers in the disaster risk field would have to, like, I guess, collaborate more with what's it called? Yeah, the government, and also like just like public policy side, because us as researchers, we're kind of like simulating and like presenting numbers to like how different people can recover, and then we're like suggesting like, oh, we should, I don't know, give like special financing programs to minorities or people with lower income. But of course, that's like easier said than done, and that's where like public policy has to come in. And yeah, it's I think it's a lot of collaboration between many different fields and sectors.
Yeah, thank you very much for those insights. Yeah, I think it's just really interesting to see. Yeah, I took a project finance class back at Stanford, and it was really interesting to see like how private and public actors, like they like if they like just knowing how or like being able to coordinate how they work well together is actually very useful. Yeah, and actually I heard Friday, I think you had a few slides they wanted to share, just like kind of like this example of like how yeah, of like kind of your work, and just yeah, how like an example of this kind of like dynamic between in public actors and this field.
Oh, sure. I kind of prepared it for like a lengthier slide, so maybe I'll, given the time, maybe I'll just focus on addressing related to your question on.
Sounds good.
It's good. Okay. Sure. Okay. So very briefly. Okay. Few percent. Can you all see my screen?
Yes.
Okay. So in my consultancy with the TGUPP Jakarta, the question that we focused on is how do we reduce or divert household organic waste? So basically, sampah dapur. How do we prevent that from going to landfill? And the major motivation behind this was that, you know, Jakarta province produces like the equivalent of like 1 Borobudur every single day, or like 77,000 tons of trash every single day. And we're sending that to Bantar Gebang, our single landfill, and it's supposed to be reaching maximum capacity by 2021, which is this year. So, you know, big issue, very urgent, very time sensitive. That was the question I focused on. And very quickly, so onto the question of what's the role of the government, what's the role of private sector. One of the things that I did with Jane was map out what happens with the trash, what happens with that nasi bungkus that you buy and you're done with it or you're half eaten it. And what we see is like we have this idealized map of the journey of this trash from like the household to in front of your to like the little bucket in front of your house, and then goes to the TPS, goes to the recycling facility, is processed, and then eventually it gets either it goes and becomes compost, gets reused, or goes to Bantar Gebang landfill. And then, so this is the idealized version. But what we found is that, you know, at every single stage, there are many gaps. And this is being generous. And these gaps are acknowledged by like government, by community, the communities we talk to, and they're very serious. They break down this entire chain. And the ideas of like, oh, you know, we have a problem, we have this intervention to solve it, and we will solve that problem, no longer becomes feasible because it's no longer that simple. And I think this is where, you know, going back to your question of like, what's the role of government, what's the role of private sector, it really, Irene was like absolutely right that it really takes all sorts of actors because there's so many gaps in terms of capacity, in terms of technical knowledge, in terms of like resources, and especially for
a country like ours with our limited resources and just acknowledging where we are, we cannot do this alone. Well, so maybe I'll like stop there, Ricky, because I know like we have limited time and
yeah, thank you so much. No, it's really, really cool to see like it actually like the actual like nooks and crannies of your work. I think that is very, very helpful.
It's also depressing, but yeah.
Yeah, I think so. Yeah, considering just the time, we'll just move into questions from the audience. And so yeah, the first question to Professor Rahardianto. What made you move from an academic career to work in private sector?
I think, and this is, I think this is probably one of the reason why my career has been sort of unusual in a way that even when I began my PhD career, I never really taught myself of, spending my whole career in the academia, because most of the time when I was in the academia, I was really working on, things that are very applied, working on essentially leading to something that would produces an invention that could lead to a private venture, basically, and that was sort of like my end goal at that time. So I don't know. I think in the beginning, when I started my PhD, I never taught myself of actually going and spend myself, becoming a professor, and that's why I never thought that, this was the career that I wanted to pursue, becoming a tenure track type of professor and be a pure academic, and that's why I chose this sort of like very unusual career path where I'm sort of in between the industry and the academia, working on projects that are very applied, with a lot of private collaboration as well, and leading up to essentially a startup, and that's where my passion is, doing engineering in that sense. So I don't know if that answered the question.
Yeah, I think it did. I think it did. Yeah, thank you so much for that insight. The next question is for Irene. And the question is your research focused on vertical infrastructure or horizontal structure resiliency? And does this include the transportation network in the areas that you are researching?
Yeah, so my focus is, I guess, on vertical infrastructure, which I guess means buildings. My focus is on either houses, actually, or like houses that, single family houses, or public facilities like schools. That's what my current project is on public schools. I don't particularly, I guess, incorporate horizontal infrastructure like transportation network or power network or gas or water. But in Stanford, in I guess our group, the Stanford Urban Resilience Initiative, there are other PhD students that work on that. And there's lots of research that are now trying to incorporate all those different aspects of infrastructure, I guess. Yeah.
Thank you very much. Yeah, Stanford has a lot of really, really cool centers I wish I explored more during undergrad. Yeah, I think my next question, this is more for Kafarida. And this is just going to the point of like, in terms of like public policy, right? Public compliance to regulations is very important. I guess like through your work, like what, and like what, I guess like what methods or like what things have you seen been successful in like showing people like this is like a very important, like this is a very important thing to to comply with, and like just like showing people the value of the public initiatives, whether it's the ones that you work on or maybe just in general, as a for in terms of like public policy.
I think like that's a I think that's a very challenging question to answer when it's general, because there are principles to apply. Like for example, like when you're approaching a question like that, understand the group that you are targeting, understanding what kind of incentives that they might be experiencing, their lived experiences and how they might react to the policies. But really, when it's it's really difficult to generalize across different questions. Do you have something more specific in mind, or was this a question from
so
the audience?
It's an audience question. Okay. I guess like just generally like maybe also like the difference between like maybe US versus Indonesia. Like I'm pretty sure like the way that you approach public policy in the two countries are different. I know like that doesn't get like too specific, but yeah, just like general differences that you've seen.
Well, so I think context plays a big part. I think like going back into like the three principles that I mentioned before was, what is technically accurate? What evidence can you rely on to let you know, to guide you? These are the interventions that work in this context. For like India, in terms of social protection, India has like a really strong literature on interventions that some Indonesia we might not have as much. So like what wealth of knowledge can we rely on? And then the second aspect is what is feasible, and this is determined very much by context. And I think this may be where the US, where Indonesia and many other countries differ, where Indonesian districts or cities differ, depending on like what's the connectivity, what's the education levels of citizens, so that they're more receptive to different mediums or different messages, or what's the geography or the terrain like, what becomes, that influences what becomes feasible. And then the last aspect is, the politics of it. And I think for a place that might be more top down, more centralized, and more like autocratic, then maybe that wouldn't have as much of a weight. But for Indonesia, I think it still does very much, and maybe for the US, it's quite polarized. So also very strong.
Yeah, very, very interesting. I think like especially like for just for students that are studying in the States and studying in Indonesia, it's very interesting to see like how like we learn about a lot of like topics in the States that are like, oh, this works like this works within the context of the political climate of the US, but like it is a bit different in Indonesia. So it's really, 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 really cool to see your thoughts on that. So another question back to Professor Rahardianto. The question is, how much energy is needed to run the RO system? Is it possible to run it completely off the grid? And I think this is probably like pertaining to your to how like you've tried to like help implement RO systems in like more remote areas.
Oh yeah, you can call me Andy. Andy is fine. My last name is kind of hard to pronounce sometimes.
That's good.
Even when I was teaching, my students just call me Andy, so I'm good with that. RO energy cost will depend on the specific water type, right? So because when you think of RO, it's a pressure-based, it's a pressure-driven separation system, and the pressure that you apply is dependent on the osmotic pressure that is in the water, that is dependent on the salinity of the water. So water that is, very, very high in terms of salinity, like seawater, will have will require higher pressure. But let's say water that now are used are used, like almost everywhere in the world for treatment. Let's say RO is used for wastewater reclamation, for example. The salinity is low, so the energy cost is very, very low. So you have to. It's really you can't you can't pinpoint a number because it really depends on the feed water. But what I can say is that for seawater, from all the technologies that are available out there for desalinating seawater right now, the most the commercial technology that is most energy efficient is RO. Nothing can beat RO at this point. In the future, there are other technologies that are being developed, but they're not practical yet. But so far, RO is the most energy efficient, and people have shown that it's very, very close to the thermodynamic limit for desalination. Obviously, there's still some room to improve, especially for the lower salinity water. But it's pretty efficient in terms of energy use.
Yeah, thank you very much. And yeah, this is another question for Irene. Is there a quick / less costly way to improve Indonesia's disaster resilience?
That's a good question. Where to start? So, of course, because Indonesia is located where it's located, disaster is going to happen no matter what. So we can't really prevent that from happening. So I think actually one of the least cost way is to prevent buildings or like infrastructure getting destroyed in the first place. And I guess if you paid attention to the recent disasters that happened in Indonesia, whether it be Lombok, Palu, East Java recently, and all the others, most of the things that get damaged are residential houses, and that's because they are not, I guess, built to code standards or like earthquake resistant standards. And I think, yeah, one of the first things we should do, and what the government should, I guess, crack down more, is to help residents build these more earthquake resistant structures. And I guess educate the people to what the risks are with these disasters. Yeah, I think that's my answer for that.
Yeah, thank you so much. And I think, yeah, just actually kind of piggybacking off of that, we had another question from the audience, which is to all the speakers, in your opinion, what country has been doing great in sustainability and resilience and policy making that Indonesia should look up to as an example?
I'm not a policy person, so I don't think I'm qualified to answer that question. Maybe Frida or Irene, can provide that. But I just wanted to give this a little bit of comment on that question. Even in the U.S., there are a lot of, we can always think that the U.S. is a great place for policy making, but there's a lot of challenges that you often don't see, and so policy is always it's a challenging issue, especially with infrastructure. The use of public goods, always an issue.
Yeah. Similarly, I want to caveat this with like, I don't know the full breadth, and so if someone knows, they should leave a comment. But for waste management, the countries that we've been looking to and that I think Jakarta has been visiting to compared with is Japan. So Japan in general, but also there's been smaller municipals or towns that have been particularly innovative and effective
specifically for the waste management point of view. Yeah, I want to emphasize though, like in terms of plastics and like recycling, this is something that like the entire world is pretty much like still figuring out, and that's why like there's such a big crisis around waste, like not just organic, because like technically you could just, you know, it's not that simple, but technically you could compost it, but like plastics, what you actually do with it, it's part of such a bigger question.
Yeah, and then for the disaster resilience side, I think I also kind of agree with Frida. There's no one country that has figured it out. Disasters are very, very dependent on where they're located, and like the effect it has really depends on what country, what city is affected. So I think, I do think Indonesia kind of like takes in from like experiences from different countries, and they do collaborate with other countries in trying to help reduce this risk. So for example, after the Padang 2009 earthquake, Indonesia did collaborate with like Australian government to help, I guess, collect data and figure out what happened and how we can learn for future disasters. But yeah, different countries have their different pros and cons and different challenges that they have to face. So it's definitely a challenge.
Yeah, and maybe like to add something to that is that, you know, we might see that like for example, in waste management, Japan is doing really well. But, you know, is it applicable to Indonesia? And, you know, what worked with them, say in the 60s, might not work for us presently. And in the same way, what works for us, you know, 5 years ago might not work for us now. Like, I think right now, a big question is how do we deal with like the medical waste? You know, and so I think this is very much like an adaptive challenge for the government. So, you know, we might see like these like 5-minute clips about like how Sweden is doing it and how Jakarta should be like Indonesia should be like Sweden. It's really not that simple. And I feel like we should be more critical when we like consume that stuff. Like, still useful, but you know, with a lot of salt.
Yeah, I think I definitely agree. Like, there's a lot of like, oh, if Indonesia was like is like Japan or like Sweden, like yes, but yeah, Indonesia is not either of those countries, and like like Prof. Andi and Irene, like you mentioned, it is very like it is a very complicated. There are a lot of complicated issues and a lot of confounding factors that no country has it completely taken care of. And I guess the next question is for Professor Andi. And the question is, when do you think that salt water filtration will become commonplace? Yeah.
I mean, whether or not desalination is commonplace, it is. It is really commonplace in a sense, in a way that you know, you could. I mean, like RO are already used in households. I'm sure that even in Indonesia, you find, you know, they're everywhere. The question is, you know, whether or not you know, you make it more. I mean, obviously, if you make it more cost effective to apply, it'll find a lot more you know, applications. But RO application is quite, I mean, I would say it's quite commonplace already in you know, many parts of the world, in the boating industry, in the water treatment industry, and the hotel industry, and I mean, even in consumer product, people use it. You know, but whether or not it can produce the volume that is needed to in a cost-effective manner, is still, you know, there's still a lot of work to for that, and I think part of the answer there is, there's a lot of move, not just in our industry, but in the water industry, this whole idea of infrastructure digitalization, making it more, easily more resilient. And I think that's going to bring, a lot of the costs down and make, a lot of the water treatment technology become more easily applicable. And that's one of the, is it okay if I ask questions to the other speaker? And I'm just wondering, is this out of, because I've been seeing, the data sciences, machine learning, things like that has been permeating to my field like, crazy. People are learning it. So I just wanted to hear if you see the same thing in your field, Irene and Frida, and perhaps share with the audience how, what's is that, something, is that an important skill to learn, and what have you done to try to, develop some expertise in that area? Because I noticed that it's permeating everywhere in many fields. So I'm just curious about that.
Maybe I'll start first. So it's definitely something that I hear everywhere. And I don't think that's necessarily like a good thing. It's a very like sexy and hot, and everyone wants to implement machine learning and AI to solve every problem. And so I think like it depends like what perspective you're looking at. I think from like my perspective as someone interested in the policy making space and like improving service delivery, like again, a huge sprinkling of salt when I think about AI, because everyone wants to use it, but do they even know what it means? Do we even have like do they even know what it means? Do we have the data to support that? Do we have the check and balances to refine the results when there's something broken like beyond that? And I think before going into AI and machine learning, I think a lot of the challenges that we're facing in public policy, like the findings of AI, assuming that we can find a lot with that, they cannot be translated to good policy design or to good policy delivery if institutions are not modernized, if institutions don't talk with each other, if we're not building with our citizens in mind. And so, from the policy perspective, I feel like there's these more basic fundamental aspects that we really need to work on. But from the student aspect, if you want to learn that, there's hot demand, go for it. Also learn how to communicate this to people who are asking for it, because that's also very, very high demand, and you'll be doing some real good, I hope.
There you go.
Yeah, and then for me, I'm sure, Ricky, you can say stuff about it too, but because it's Stanford, almost every student takes some CS classes. I took CS classes too. I took machine learning, and so it's pretty much every day that we hear it. As for the application to disaster risk and like structural engineering is in general a more slow field, which is why I guess it's just starting to catch on, and like people are now like starting to collect data to like train these models and do predictions and whatnot. But there's actually some very good advancements, I think, using machine learning and AI for disaster what's it called, post-disaster assessment. So basically what happens after disaster when all these like buildings are damaged, normally people would have to go out on the field and manually inspect every single building that's damaged. And they have to like see like, oh, there's a crack in this column or there's a crack in this wall, and like they have to manually write it down and like combine it into some sort of database. But so what is happening is that we're now starting to use satellite images, which has grown in like their resolution is incredible now, right? Like there's like, I don't know, like 1-2 meter resolution images. So you can see like very, very detailed of like, the infrastructure and buildings from space immediately after a disaster. And so it definitely like speeds up that process of those months and months of field surveys after disaster, and you can basically like map out which areas are damaged, which buildings are damaged, probably like, a couple of days after a major disaster. And I think that's one of like what I would say one of the coolest what's it called, implementation of machine learning in like disasters. But of course, it's also not as simple as that. There's many problems to that. As Frida said, basically you can't really just rely blindly on it. You really do have to understand what the limitations are, how exactly it works. And you can't, I don't think it would be good for someone to use it if they really don't know like the fundamentals behind it and like what the limitations are, because then it'll be very dangerous.
And in some fields, the data are not yet available, or they're very rare. That's also a big challenge, I think.
Yeah, a quick plug though. I think like I don't want to like poo-poo on AI and machine learning. But I for like I know that Pulse Lab Jakarta is doing some really cool work on how they use like large amounts of data to inform a wide range of policy decisions. So if you're interested in how those machine learning that's being applied, check out Pulse Lab Jakarta.
Yeah, no, thank you, Professor Andi, for that was actually one of the questions I had in mind. That
sorry,
no,
sorry to take that away from you. So
because I wasn't sure we would get to it. It's really cool. As Irene said, like I'm actually taking like an AI and construction class at Stanford. It's really interesting to like your points of like how to Frida's point of like the main thing that they teach is not like, oh, you can like, it is really cool how you can use like convolutional neural networks, satellite imagery, natural language processing. But like the number one thing is like, do you actually know what the problem is? Do you have the data for it? Like Professor Andi, like you said, and like, can you actually like apply it, right? Like that's like all the programs on like AWS and whatnot like are already done, but like you need to actually know kind of like how it's applied. So yeah, I that was a really cool discussion. I'm really glad. Really glad I came out. And I think so. I think I guess just for the sake of time and because I don't want to. Sorry, Professor Andi, do you have something to say?
No. I'm just.
Okay,
Go
sorry.
ahead.
Just for the sake of time and apologies to the other participants that ask questions, just so we can be respectful of everyone's time. But yeah, I guess like one thing I wanted to end on is generally like Warekada was made for just to like get together like people that are really interested in certain fields and like get expertise from people that have already succeeded in academia in the States. And so yeah, I guess like what would for each of you, what would your advice be for them just in general of getting into academia in the States, or particularly in the fields that you are in? And this goes to all the speakers.
Okay, I just have three things that I want to end with. First is I really like to see more Indonesians to enter the water technology field. It's a challenging field in a sense that the industry is very conservative and accepting the technology, but it's a critical area, and Indonesia is faced with a lot of the water issues as well. And every time I go to conferences, I really want to see more of people coming from Indonesia to enter the field. The second one is I think don't limit yourself to your field to your field, because instead try to explore many ways you can apply your knowledge and experience to your problem of interest, regardless of the field. The truth is, unless you stay in the academia, more likely you're going to end up in something very different than your graduate work. So even when you're in academia, you change, you will expand. You're going to work on fields that are maybe so unrelated to what you did in your graduate work. So focus on the fundamentals, the critical thinking, scientific methodology, engineering and design skills, things like that. And the last one, I think, is sort of answer the question that you had is, and this is, I think, is very important. I wish I had known this more. Is like mentors. I mean, you really need to create your community of mentors. Don't just get one mentor, get multiple mentors, meet with them regularly. Talk to people that you like and ask them, hey, can I talk to you, let's say every month, and just bounce off ideas. Can you be my sounding board and talk about your career and your projects? And this is how knowledge are passed, right? How you can advance not in a vacuum, and this is going to help. So having a community of mentors as early as you are in your career is very, very important. So those are just the 3 takeaways that I'd like to share with you guys.
Thank you very much, Kak Frida, Kak Irene.
Yeah, I can go. Ricky, does this apply to academia, meaning like apply to school? Apply to
It can be
grad
anything.
school?
It can be anything. Just like, yeah, applying to grad school. Like, how do you think about grad school? Like, what tips and tricks do you have for people like maybe starting in grad school that you realize like, oh, this is really important for a first year PhD student or a master's student to know?
Yeah. Okay. I guess for being where I am, I think one of the key things I've learned is trying out as many things as possible. As Prof. Andi said, you don't really end up in the discipline you started out with. So just taking as many different classes and learning about many different fields as much as possible, I think is really good, because it just like broadens your knowledge and your perspective on things. I totally agree with the mentors thing. There's, I don't know, I feel like lately I've just been like using LinkedIn to just like find connections and like trying to get like informational interviews with them and just like see how their like careers ended up, like how they ended up there and what their career trajectory is. I feel like it's always so interesting to see their backstories and how it can relate to you. Yeah, and then I guess for if people are going to apply to grad school, I feel like Indonesians sometimes don't really realize how important essays are, and their application essays are. So I think that I really like really make like that essay stand out, and whether it be like sending it to a bunch of people to get their opinions. I think that is very, very helpful.
I love this. I wish I had like heard all of this before I started applying and did my master's. Because like I did not have the best undergrad experience, and I always thought that academia was like not academia, like school was not for me. And I think with me getting into Harvard, like I need to put it out there that a large part of it, I think, was by chance and luck that I happened to be in an organization that pushed me to go take a master's. And so I think, if I'm speaking to someone who's thinking about doing a master's, and, if I'm speaking to like my past self, I think having, experience, like looking around you and like experiencing life with a curiosity and like awareness, I think that's a big thing, because as Prof. Andi and Irene has said, you never know from the start what you want to be doing. and follow that curiosity and like explore those questions. And Indonesia, I think we're focused a lot on like looking abroad, see what the best practices are. But Indonesia is such a rich and unique and weird context, and so understudied, and we're like bringing so much to the table. When we go abroad and we study, the things that like perspectives that we're bringing are really valuable, and like don't undervalue that. And so if you're applying and you're going, it's going to be hard going there. It's going to be hard getting in. It's going to be hard doing it. So have a clear purpose of why you want to do this. What is it you want to achieve? What's the end goal you're working towards? And like lastly, to emphasize what's been said, don't limit yourself. Take risks. Like, school is the time when you when everything is low risk. So like, put yourself out there. Apply to the things you think you'll get rejected. Rejection will make you stronger. Just like go forth and do it.
And for those who are undergraduate work, I just wanted to say that there's light at the end of the tunnel.
My husband's in the PhD
mean.
program, so I'll tell him that. Thanks.
Thank you. I feel that.
That's really funny. And so this, unfortunately, we have to close the session, but yeah, I really enjoyed the session. I hope the rest of our participants did too, whether you're on YouTube or on the Zoom call. And so that concludes Warekada 6, Civil and Environmental Studies. And thank you, Prof. Andi, Kak Irene, and Kak Farida for coming and talking with us today. We really appreciate your time. And thank you so much. And stay tuned for more Warekada events from PERMIAS Nasional.
Thank you. Thank you, everyone. Bye-bye.
Thank you, everyone.